We're going to talk about myelinated nerve fibers. Okay, so here we have got this is the axon, and the blue here is a fatty material, is the myelin sheath. Okay, now the myelin sheath I've drawn in cross section. I've drawn the nerve in cross section here. So you've got the axon in the middle, and wrapped around that you've got it's called the Schwann cell. And it's essentially just mostly cell membrane wrapped round and round and round. And you can see there you've got the nucleus of the Schwann cell. Now the cell membrane, of course, is very hydrophobic and very impermeable to ions and water. Okay, so and it is like it's an electrical insulator essentially around the axon. Now, when you have myelinated nerves, the nerve impulse is transmitted much more rapidly than with unmyelinated fibers, and it's also much more efficient. It uses a lot less energy. Now, let's see how that works. Okay, so first of all, let's imagine if we have an axon here. Okay, and I'm going to say we've got a few sodium channels here. So these are sodium channels, Na voltage gated channels. And we'll say that let's say that this is here, that is myelinated, that's heavily insulated, so this is the myelin sheath. Okay, so what happens, an action potential comes down this nerve here, and when the voltage goes up, when it becomes depolarized, the voltage, plus 40 millivolts, whatever, what is going to happen is you're going to get a big influx of sodium ions through those channels here. Lots of sodium ions are going to come in here. So what we're going to have very high sodium concentration here. Now, if you think about the axon, it's very thin. This has got a very low volume. So just a few, a lot of sodium ions coming in here at this region will make the sodium ion concentration high here. Because it's such a small volume, you're also going to get a pretty high concentration here. And that will remain high. Okay, it will get slightly less high. So let's call it medium Na plus concentration. As it has to diffuse further down, it's going to get more and more diluted. Fair enough, but it's still going to be fairly high. However, eventually, if we have this for, let's draw a dotted line here. If you have this for a really long way, then you can probably appreciate that it's going to be not very high sodium. So it's going to be lowish Na plus concentration. So that means that the membrane has become, well, it's not fully depolarized here. And eventually that depolarization, as you get further down there, the depolarization is going to attenuate, it's going to die off. So what it needs every now and again is a little boost, and that's when you have one of the gaps in the myelinating. So this is called the Node of Ranvier. As you probably know, there's a Node of Ranvier, and what you find in the Node of Ranvier is at the nodes, there's the myelin there, sorry, you have a high concentration of sodium channels, sodium voltage gated channels. You have them here. You don't have any sodium channels in the rest of the membrane, just at the nodes. And of course, if the membrane is sufficiently depolarized, and it will be, then you're going to get a load of sodium ions coming in here, and that is just going to boost the level of depolarization. So you can get sodium going in there, and it's just going to boost it again, and that's going to keep it depolarized until it gets to the next node, and so on. So as you can see, we draw a little diagram here. The nerve impulse is usually described as jumping from node to node. I don't really like that description, but that's the way it usually describes it. So that it just needs to be, because those sodium ions, the concentration of them is going to die off with time. As the distance gets longer, it needs a boost. So you get an injection of more sodium ions at each node. Node of Ranvier, there. And so it's usually described as jumping from node to node to node. And that is called saltatory, means jumping, saltatory conduction. It's much more rapid than when you don't have myelinated fibers. And also the sodium-potassium pump has to be less active, because in all of these parts of the membrane here, you aren't getting any, there's very little leakage of sodium ions at all.